All right, talking about the generalization of results, we spoke about this last week. Being able to generalize your results is central to evidence-based practice. The best current research evidence to meet the needs of the individual clients. There are two basic procedures for improving external validity. They include systematic replication and subject randomization. Subject randomization. Selecting random samples of people, settings, and times. Comprising a group of subjects likely to be more representative of characteristics of a target population than non-random samples. There's simple random sampling. We could look at sampling of settings, values of the independent variable, times of measurement, stimulus materials, and other measurement procedures. Remember, though, I said last week, there has to be a balance between internal validity and external validity. So what variables are you controlling for? What variables are you looking at? What do you want to be able to extend to your the general population? There are certain types of sampling we could do. We could do stratified random sampling, where you can take an accessible population and divide it and categorize it into subgroups or strata, from which subjects are then drawn randomly for sex, age, etc. Or cluster sampling, where all subjects are members of a group that was selected at random. The sample size. The larger your sample size, the easier it is to make generalizations. So studies that have larger sample sizes are considered stronger than studies with small n's, because a larger sample will more closely approximate the characteristics of a population. Study replication is another effective method to improve generalizations. Findings that have been replicated have stronger external validity. So remember that video we watched from Amy Cuddy, and then I showed you that article where a lot of her research was debunked because it wasn't able to be replicated. So replication helps improve generalization. You could do direct replication, where you extend generalizations to the same population, setting, or variables, or you can change things a little bit. So if I were to do a study only on college students, but then I wanted to be able to generalize my results to people in their 30s, I could do the exact same study to the age group of people in their 30s, and then it would be said that I replicated the study, and therefore the results I found in the college-age students were the same as the results for the students in their 30s. So this, direct replication is useful when it's impractical for an investigator to study, like I said, a lot of research is done on college campuses, so a lot of people in research studies are college age. Then let's say that's more practical for a researcher in a university, but then he found good results, so then he was able to get enough grant money and do the experiment again, but in a city where he had a more diverse age group of people to work from. With systematic replication, the research might be repeated under different conditions or with different subjects. And again, like I said, it helps extend generalizations to other subjects, settings, measurements, and treatments. So we could do it on new populations, new settings, new treatment for whatever the investigator wants to generalize the results. So this lets a researcher extend their validity beyond the limits of a single study. In summary, external validity or generalizability of results is usually limited in any single research study. Random sampling or direct replication helps improve generalization within the limits of certain types of subjects and setting. And systematic replication, that would be my example of going from, college age group to a group in their 30s, doing the exact same study but on a different population or a different setting or a different measurement. That's not direct replication. I was ahead of myself. Direct replication is what got Amy Cuddy in trouble with that power pose study.